So that was interesting. I guess if I get a phone call, it stops my recording and it tries to answer the phone call on my iPad here. So my apologies. I rewound it to see where I left off, and what happens is all we did was we solved the second equation for A, and we got A is -7. And as you can see here, we checked that A equals -5 makes the equation true. We checked that A equals -7 makes the equation true. And so we can see that both A equaling -5 and A equaling 7, since they both make the equation true, they are the solution to the equation. Ah, that's nice. Thank you for that too. All right, time back in. Now, as we look here at example 5, we notice that this equation is not in quadratic equals 0 form, so I can't try to solve it yet. The first thing I need to do is get all the terms over to one side with 0 on the other side. So that's the thing that I want you to keep in mind. The other thing I want you to keep in mind is it's almost always easier to solve the equation when the quadratic term, which is this -m² term, is positive. So since it's negative here, I'm going to go ahead and add m² to both sides. And when we do that, and putting the terms in order over here, we could write 40 plus m², but instead I'm going to write m² plus 40 equals, on the right side, since -m² and m² cancel each other out, the right side we just have 13m. Well, we still don't have the quadratic equaling 0, so we're going to go ahead and subtract 13m from both sides. And again, writing the terms in order of descending powers of m. So m to the second, m to the first, which is -13m, and then the constant term gives us plus 40 equals 0. So now we have the quadratic equals 0. And now we can go ahead and proceed the way we've done before. We're going to factor the left side, m and m as the first factors. Think of this, factors of 40 that have a sum of -13, or factors of 40 that add up to -13. 2 and 20, 1 and 40, 4 and 10, 5 and 8. So 5 and 8 multiply together to give you 40, and they add together to give you 13, but since it's -13, we need a -8 and a -5. So we have our two factors of 40 that add up to -13. Then again, we're going to set each factor equal to 0. We have m minus 5 equals 0, m minus 8 equals 0. Adding 5 to both sides here to get the variable by itself. Adding 8 to both sides here to get the variable by itself. I'm getting lazy, not putting my red pen down in between each one. So we get m equals 5, and we get m equals 8. So the -8 and the +8 cancel. We get m equals 5, m equals 8. I'm going to leave the check to you, so maybe by now you look at this and you go, okay, 5 minus 5. Well, actually, I take it back. Let's check in the original equation. It's more difficult to check in the original equation, but we're going to go ahead and do that anyway, just to show. The question is 40 equal to putting a 5 in for m, -5² plus 13 times 5, and you might think, well, that might be 25, but it's not 25. Does 40 equal -5²? We square the 5 first, we get -25 plus 65, and -25 plus 25 does indeed equal 40. So 40 equals 40 check, which means that 5 makes the original equation true, and I'm confident that 8 does too, and I don't want to show it right now, so I won't. And I'm going to pause the video and flip over to the next page. In example number 7, we have a quadratic equation, but we don't have a quadratic equaling 0, so we're going to move the terms all to one side, and in moving the terms all to one side, we get a quadratic equaling 0. Now, what you might notice here is that we only have two terms, which is okay. We can still factor those two terms. We can factor out a v. We see that a v is common to both terms. When we factor out a v, we get two factors. Now, it would be completely incorrect to go ahead and divide both sides by v, because what you'd be doing is ultimately dividing out the v, which when you do that, you're going to be eliminating one of your solutions. Normally we see two terms as one factor multiplied by two terms as the other factor, but we don't have that. But just v equaling 0, that's an okay factor by itself. Again, we have one factor multiplied by the other, and when you have one factor multiplied by the other, you set each factor equal to 0, even if one of those factors is only one variable. So that already solves itself. V equaling 0, we don't have to do any work for that. Here, over here we have plus 8 on both sides, and when you add 8 to both sides, we get v is equal to 8. So we get two solutions, v equals 8 and v equals 0. And keep in mind, when you have a v multiplied by another factor, you can't just divide by the v. Okay, because you can't divide by 0, and you'd be dividing by a variable that might be 0.